Assalamu alaikum. Welcome to the second draft presentation of our paper titled DSE Stock Price Simulation, a Comparative Study. I am ID 2224138 SM Rakib Hassan. My ST Apo is Farah bint Hakapo and research assistant sir is Muhammad Humayun Kabir Mehdi sir. So in our previous draft, we have discussed the abstract, the aim of this paper, and the literature works along with some of the methodologies. So today we'll discuss the result collection and analysis part and the later parts. So each model we have used, which are RNN, random forest, LSTM, and GRU. They generate predictions for the test set which were collected for comparison. The output included predicted stock prices for the given horizon, which in this study likely range from the next day to several days ahead. Okay, by meticulously executing these steps, the study ensured that the subsequent machine learning models were trained and evaluated on high quality, well understood data, increasing the robustness and reliability of the forecasting results. So now let's come to the experimental setup of our research. This experimental framework of our study was meticulously designed to evaluate the predictive performance of a suite of advanced machine learning models. We carefully selected and tailored each model to address the unique challenges posed by the stock price prediction task, leveraging their respective strengths in capturing temporal dependencies and complex patterns within the high dimensional data from the Dhaka Stock Exchange. So, the code is made open source and it is available in Kaggle. So if we go to the link given in abstract, we can just see how we have deployed each of the models and discussed its viabilities. So each model is discussed separately, and at last we have made a combined visualization. So let's go back to the paper. So first we have used the random forest. It leverages an ensemble decision trees to make robust predictions and mitigate overfit and outputs like average prediction of the individual trees for regression tasks. So it is basically a very simple machine learning model which uses a number of decision trees to create a forest and goes randomly to make a regression task. Then we have used the long short-term memory or LSTM. Long short-term memory networks are a type of recurrent neural networks designed to learn order dependencies in sequence prediction problems. So these are very good models for sequence or time series prediction. LSTMs have a chain-like structure with repeating models of neural networks consisting of different interacting layers. The key equations governing an LSTM unit are in the equations. We trained the model for 30 epochs using a learning rate of 0.001 and employed the Adam optimizer. The training process involved fitting the model to the training data with a batch size of 32, a mean squared error loss function, and a validation split of 20%. Then we have used the gated recurrent unit or GRU. GRU is also a very popular model for forecasting time series prediction and things like share market predictions or financial predictions. So gated recurrent units are the LSTM models with a similar performance, merging the forget and input gates into a single update gate and combining the self state and hidden state. So the basic principle is given in this equation. We trained the GRU model for 30 epochs, same as the LSTM, and other parameters was also almost same as the LSTM, and we used a GRU layer consisting of 50 units with a dropout layer with a dropout rate of 0.2 and dense output layer with 1 unit. Then we have used a recurrent neural network or RNN model, which is a basic form of neural network where connections between units form a directed cycle. So this creates an internal state that allows the network to exhibit temporal dynamic behavior. A simple RNN is described in this equation. We have trained the RNN model by constructing a sequential model comprising a simple RNN layer with 50 units, followed by a dropout layer with 0.2 dropout rate and a dense output layer with 1 unit. The model was compiled using the Adam optimizer as the other models were done so with a learning rate of 0.001 and a mean squared error loss function. So in loss functions, we have not only employed the mean squared error, we have also employed other one loss function, which is coefficient of determination. So the mean squared error is a commonly employed loss function in regression type tasks, which is depicted in this equation. A lower MAC means a better model performance. And for the coefficient of determination, the coefficient of determination, often denoted as R square, is a metric used to assess the goodness of fit of a regression model. It quantifies the proportion of the variance in the dependent variable that is predictable from the independent variables. So it is something like a dice coefficient which makes the overlapping score. So how much the predicted value and how much the real values are overlapping. So it ranges between 0 and 1, where 1 indicates perfect fit and values closer to 0 suggest poor model performance. So for our results and discussion, after employing these four models for predicting the stock prices, we analyzed our stocks and various methodologies from the previous works. So the analysis conducted in this study utilized various computational models, as we have discussed earlier, to predict the stock prices. Data from the Dhaka Stock Exchange were analyzed to gain insights into market trends, volatility, and predictability. So volatility analysis is a very, very important aspect in share market prediction. We have illustrated a 30-day rolling volatility revealing a significant fluctuations indicative of market instability, particularly during high impact events such as the onset of COVID-19, which we can see in early 2020s. So we analyze using a rolling standard deviation method on a daily price change similar to that approach of Stewart. It is a very early study. So for our model performance, we used the metrics MAC and R squared. Both were used to evaluate the model effectiveness following the methodology by other two previous works. In this table, we can see the model performance metrics. Then in real life prediction, predictive models offered insight into future market trends. These figures actually describe our actual versus predicted stock price for each market, demonstrating their predictive capabilities. So we can see the random forest model prediction, the LSTM prediction, the GRU prediction, and here we can see the RNN prediction. So that's all for our result analysis. So in the next part, we'll complete the paper and hopefully describe the full paper in detail. Thank you for your patience.